How are you, my friends? This is lecture 21 of the pre-calculus course, trigonometric addition and subtraction formulas. Let's start directly with the formulas that you have to remember so that you can do the questions correctly. Two formulas for the sine, two formulas for the cosine, and two formulas for the tan. Let's see, sine u plus v will be sine of the first angle u, cosine the v plus cosine of the u times sine of the v. And here we have sine u minus v will be sine of u, cosine of v minus cosine of u times sine of v. Please read the formulas carefully. Look at the signs. Remember here the cosine u plus v will be cosine of u, cosine of v minus sine of u, sine of v. Look at number 4. Now, the 5 here, number 5 formula, tan u plus v is equal to tan of the first angle u plus tan of the v divided by 1 minus tan of u times tan of v. So you can review these. Now, let's see the formulas for the cosecant, secant, and cotan. We know cosecant function is the reciprocal of the sine function. So if we need cosecant of u plus v, it will be 1 over sine u plus v, and then we know this is the formula number 1, so 1 over that formula. The formula for secant of u plus v will be 1 over cosine u plus v. And that's the formula in the denominator. Now for sure, if you need secant of u minus v, it will be 1 over cosine of u minus v. Then you can use the correct formula. For cotangent, cotan of u plus v, 1 over tan u plus v. You invert this formula for the tan, so it becomes 1 minus tan of u, tan of v, divided by tan of u plus tan of v. That is the cotan of u plus v. So we have many examples here. Let's find the exact value of cosine 75. See, 75 is not a special angle, but without using a calculator, we can find the exact value of cosine 75. So what is the idea here? We have to try to find two angles, their sum or difference. Either you have u plus v or u minus v. So 75 is easy angle, 30 plus 45. So cosine 75 will be cosine 30 plus 45 inside the bracket here. So now the 30 is the u, v is the 45. Just apply the formula. So it will be cosine 30, cosine 45 minus sine 30, sine 45. Now cosine 30 we know from the table. Cosine 45 we know square root of 2 over 2. Sine 30 we know it's half. There is a minus there. Sine 45 square root of 2 divided by 2. So you multiply these numbers. Now to find the exact value of sine pi over 12, I try to find here, since the denominator is 12, try to find a difference here that will give us pi. So 4 pi minus 3 pi is a good choice. It's not good to write like 7 pi minus 6 pi because I need two numbers divisible by 12. So if I split now the fractions here, 4 pi over 12 minus 3 pi over 12, this will be pi over 3 because you cancel the 4. Here you cancel the 3, you get pi over 4. We know this angle is special. We know this angle is special. And this is u minus v. Now, some people, they can change this to degrees and do it easier. It's up to you. It's better here to leave it as radians. Let's use formula number 2, sine u minus v. You can pause the video if you like and try it before you see the answer. So formula number 2 will say here, sine pi over 3 cosine pi over 4 minus cosine pi over 3 sine pi over 4. We know these values because these are all special values. Square root of 3 divided by 2, cosine of pi over 4, square root of 2 over 2, cosine pi over 3 will be half, etc. Then it will be square root of 6 minus square root of 2 divided by 4. Now this is a nice question. We have a tan of something here in the bracket. Theta minus 3 pi over 4 is equal to 5. So the tan of all this angle is equal to 5. We need tan of theta only. So it's a good idea. On the left side, you can use the formula. This is u minus v. And you remember the formula. So I wrote the formula here for you. This is formula number 6. U minus v, see? U minus v. Each u is like theta here. Each v, 3 pi over 4. So I write tan theta minus tan of 3 pi over 4 divided by 1 plus tan theta times tan 3 pi over 4. This is equal to 5 from the given. Continue the next slide. We know this angle, special angle, 3 pi over 4. We find the value, which is in quadrant 2. And then you cross multiply to find tan theta. So 3 pi over 4, just I'm explaining that here on the right side. It belongs to quadrant 2. The reference will be pi minus 3 pi over 4. Find the LCD here, it will be pi over 4. Multiply up and down by 4. So tan 3 pi over 4 will be minus, because it is in quadrant 2. So tan will be minus tan, the reference. The reference is very special acute angle here. So it will be minus, and then the 1 here, tan pi over 4 is 1. So I put, instead of tan 3 pi over 4, I put minus 1 there. Tan theta minus 1 becomes plus 1. And this 1 minus tan theta, cross multiply, you multiply that by 5. You bring tan thetas on the one side, that would be 6 tan theta equals to 4. Now, example number 3 is very important because we will apply so many formulas from this lecture. We have some given here, I will explain it now. Then we have to find sine of A plus B. So there are two angles, A and B. So we need to find sine A plus B, then secant A minus B, then tan of A plus B, then cotan of A plus B. So we have one given sine of A 4 over 5, A belongs to quadrant 2, cosine of B given also minus 5 over 13, B belongs to quadrant 3. So let's see, since we have one function here, sine of A is equal to 4 over 5, that will be y over r. This is in quadrant 2. So I can find the x, you know, x squared plus y squared is equal to r squared. Put the numbers there, so x will be minus 3 because A is in quadrant 2. So we need cosine of A, which is x over r minus 3 over 5. So this part only to find cosine of A. See, sine of A is given from the triangle, I can find cosine of A. Same thing for B. Cosine of B is given, which is minus 5 over 13 in quadrant 3. Y, x is negative here, you see. Y also is negative. Put x squared plus y squared is equal to r squared. So y will be minus 12. Also because B in quadrant 3. So given cosine of B, I found sine of B. So now I have everything I need. Sine of A, cosine of A, cosine of B, sine of B. Then we can proceed. See, this is what I have here. First part, A, sine of A plus B, just use the formula. Sine of A times cosine of B plus cosine of A, sine of B. I know all these numbers, just be careful about the signs. Sine of A here positive, cosine of B minus 5 over 13, etc. You multiply the first two, you get minus 20 over 65, and this one 36 over 65. When you add, you get 16 over 65. This is the sine of A plus B. Let's continue now. Now we need cosine of A minus B, because in B part, I need secant of A minus B, which is 1 over cosine of A minus B. So first I find the cosine of A minus B. Put the correct formula. Cosine of A times cosine of B plus sine of A, sine of B. I know these numbers there. 2 were given, 2 were found. And then it will be 15 here over 65 minus 48 over 65. It will be minus 33 over 65. When you need the secant of A minus B, just the reciprocal of the cosine of A minus B. So it will be minus 65 over 33. Now let's go to C part, which is the tan A plus B, the nice formula number 5, tan of A plus tan of B divided by 1 minus tan of A times tan of B. You have to remember the formulas correctly. So we know sine of A and cosine of A, so I can find tan of A. Just divide sine of A by cosine of A, you get tan of A, which is negative minus 4 over 3. Cosine of B we know, sine of B we know. When you find tan of B, it will be sine of B divided by cosine of B. It will be positive because B in quadrant 3, 12 over 5. Now just be careful here about the signs. Tan of A, I put minus 4 over 3. Tan of B, 12 over 5. 1 minus this one times 12 over 5. So we continue in the next slide. You can take a minute here, please. You can just try these fractions until you see the number. So first here we find the LCD 15, so that will be 16 over 15. And here 1 plus 48 over 15. So the whole answer will be 16 over 63. This is C part. D part will be cotan of A plus B, which is the reciprocal. 1 over tan A plus B, which is 63 over 16. In case you need cotan of A minus B, you have to find 1 over tan A minus B. Then find first tan of A minus B, then take the reciprocal. Example 4 is easy question, I think. Simplify the expression sine pi over 6 plus theta plus cosine pi over 3 plus theta. Here we have sine and here we have the sum. Here we have cosine and also the sum. So let's find two formulas here. See the sine of the sum. This will be quadrant 1. See, this is the question here. So I can say sine pi over 6 cosine theta there plus cosine, the first angle, this is U and V, sine of the theta. See the plus here, the plus, the 3 lines there. Cosine, formula number 3, cosine pi over 3, cosine the theta minus sine pi over 3 sine theta. Please be careful about this line here. I applied 2 formulas there. Formula number 1, formula number 3. Then we proceed here. Sine pi over 6 will be half times this cosine of theta. This will be square root of 3 over 2 times sine of theta plus, still all plus. Half, this is half cosine of theta minus square root of 3 over 2 cosine of the theta. Now, which one is cancelled? This is a plus here. See the same number there, plus and minus, they canceled. We have half cosine of x theta plus half cosine of theta. This is what I wrote here. If you have something like half of d plus half of d, it will be d. You see the same LCD here, the same number, 2. So d plus d, 2d over 2 will be d. So half of cosine theta, suppose cosine theta is capital M, half capital M plus half capital M. So the answer cosine theta for the whole expression. Now this is really very important because we have sine of the sum. There are 2 angles there and there is inverse. Inverse trigonometric functions is lecture 19. So sine of cosine inverse minus 3 over 5 plus, see the plus here, that's addition, tan inverse minus 1 over 3. So this is an angle here, plus another angle. We need sine of the sum. Now let's start the solution by letting the first angle here, cosine inverse minus 3 over 5, is equal to theta. The second angle, tan inverse minus 1 over 3, is equal to alpha. So the whole question now becomes sine theta plus alpha, which is so easy to use the formula. The formula for sine u plus v. You can say let u is equal to this, let v is equal to that. You can do that. But I decided to put here theta and alpha. So let's start here, the two right triangles. Let theta is equal to this cosine inverse minus 3 over 5. Then cosine of theta will be minus 3 over 5, which is x over r. Then I can find y. Now y is positive here. You put x squared plus y squared is equal r squared. X is negative because that's cosine of theta will be x over r. The cosine inverse, if you remember in the cosine inverse, it's defined from 0 to pi, which is quadrant 1 and 2. So y will be positive in that case. Let alpha will be tan inverse minus 1 over 3. So tan of the alpha will be minus 1 over 3, which is y over the x. Then I can find r, which is square root of 10r is always positive. Now from the two right triangles, I can say sine of theta, because I know cosine of theta minus 3 over 5, sine of theta will be y over r, which is 4 over 5. Now from the alpha, I need to find sine of alpha, cosine of alpha by the definition, sine of alpha y over r, cosine of the alpha x over r. Now let's use the addition formula for sine. So sine theta plus alpha, which we need, is equal to sine of theta cosine of alpha plus cosine of theta sine of alpha. Let's continue on the next slide. You can try it yourself, please, before you see the solution. So now from the previous slide, we have all this information, sine of theta, cosine of theta, sine of alpha, cosine of alpha. Apply the formula. This is what we need here. You see, sine of cosine inverse of this plus tan inverse of this. This is what we need. We change that into sine theta plus alpha, then use the formula for sine theta plus alpha. Then I put the numbers there. Sine theta, you see sine theta, 4 over 5. Cosine of the alpha, 3 over square root of 10. Cosine of the theta, minus 3 over 5. Sine of the alpha, minus 1 over square root of 10. So you multiply this, you get 12 here. You see 12 over 5 square root of 10. And here you have 3. So that would be 15 over 5 square root of 10. Rationalize it. Multiply by square root of 10 up and down. So this will be 10. And here you cancel the by 5. So 3 square root of 10 over 10 is the answer. So this is lecture 21, trigonometric addition and subtraction formulas. At the end of lecture 22, which is reduction identity, you can find some old exams questions to practice on both lectures, because these are related lectures, 21 and 22. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you that this is pre-calculus course, lecture number 21. I hope I can see you in another video with another topic. Thank you very much.